So what would happen if you took SQLite, the most widely deployed database in the entire world, and you rewrote it in Rust with some new twists and new ideas? We are all going to find out because Glauber Costa and his team at Turso are working on it. It's called Limbo. Glauber, welcome to the Changelog.
Thank you. It's great to be here.
It's great to have Adam here, despite flu season hitting hard in the Stakoviak house.
Oh, man.
It sounds great, though, Adam. You sound great. You've mentioned you're on the tail end of the flu, but don't sound like
I've been trying so hard to sound better, so thank you.
Where should we start? I think this story goes back quite a ways. I remember libSQL or libSQL, which was a couple of years ago now, your guys' effort to create a different open source SQLite. I thought SQLite was open source and public domain. Can you tell that story?
Oh, happy to do that. And the story, in a sense, it's still the same story. So I think you hit the nail in the head there. It's just really how it started. I don't feel this is a completely different thing, what we're doing now. The story there is that we were using SQLite in our company. So Pekka and I, Pekka is my co-founder, we founded a company if you happen to stumble upon it, just mentioning here by name, called Chisel Strike. And it was in the API space. We were doing a bunch of things, and we were using SQLite very heavily in that company. And the reasons we were using SQLite were reasons I think that a lot of your audience will understand and relate to. Look, you would just do npm install the name of the package, and then everything's there. Your database is there, everything is there, everything works. You don't have to install anything. And just so SQLite for us always had this appeal of a database that is just always working, and then you can build stuff around it, and it's just always there. So there was always something that was very appealing to us. However, we also stumble upon this thing a little bit about SQLite not being open source. So let me address that. SQLite is a public domain software, which is technically a difference that doesn't matter, right? So I think only a lawyer would be concerned with what is the difference between public domain and open source. For all intents and purposes, it's the same difference between like the BSD license and the MIT license. I mean, it's minor. Nobody cares. I don't care. And I think nobody else does either. But SQLite is, according to their own website, by the way, this is something that they put in big bold letters in their website, open source. And again, I'm not claiming that they're wrong to say that. It's all good. Open source, but not open contribution. So when people think of an open source project, there are two things that comes to your mind. And the first one is like the code is open, and SQLite is that. But you also think about, instinctively, the code's going to be on GitHub somehow. And then if I find an issue, I can go contribute to this project. And I have some source of ownership to the code, right? Just it's not just that I can see the code, I can also modify the code. So that's usually classically one of the tenets of open source. Now, SQLite is not like that. The maintainers of SQLite, the creators of SQLite, do not take contributions. This is not something that we are saying. This is something that they're saying. Yes, I mean, I think it happened in the past that people managed to contribute to SQLite in very special occasions, but it's not a project that is designed to take contributions from other people, right? So that is how SQLite is. We started running into a couple of, hurdles with SQLite. So part of that is that we wanted to deploy our SQLite databases to the edge. We wanted to deploy it in a way that was replicated. We wanted to do things like read replicas, and we wanted to put it to run on Cloudflare workers and all things like that. And we considered this a good thing for our project. So, and technically we knew we could do it. And for context here, like Pekka and I, we've been working together. Pekka is my co-founder. We've been working together for 15 years now. We met each other when we were both working on the Linux kernel. Pekka was one of the maintainers. Each one of us worked in Linux for almost 10 years. The first 5 without knowing each other. I think we knew of each other, but we never met. And in the last 5 years, very closely to each other, where we developed a good friendship. After that, we actually joined a startup that also became a database company. We spent 8 years doing that. So we felt like SQLite is, all things considered, pretty simple. Given the scope of things that we used to do. So technically we can make the changes that we believe we can. And so let's just come up with our own version. And we saw at the time a lot of people dancing around the subject. That's what we saw. So there were some projects like LiteFS that were super interesting projects. SQLite. We saw like lots of people trying to get SQLite to work as a distributed system. The problem that we saw with all of those projects is that they were all again dancing around the subject that SQLite cannot be changed. So we're going to create layers and layers and layers around SQLite to help with that. And for us, it was like, technically, this is actually a pretty simple problem. You just have to change SQLite here, here, and here, and you're good to go. And I think the last piece of the puzzle, or maybe the two last pieces of the puzzle, number one is that we were very concerned with who's going to want to run our SQLite plus patches, because SQLite is a very trusted project. So, you make random modifications to SQLite, everybody starts distrusting what you're doing. So we knew that, look, the solution to this problem is that we should just create an open contribution version of SQLite, because now it's not like SQLite plus thing, it's its own project, and then people come to trust that this one project, and with that, like the diagnosis that we had at the time is like, hey, SQLite is great code wise. The thing that is holding it back in our reading is exactly the fact that it cannot take advantage of the dynamism of the creativity of a truly open source community. So let's create that. And the last piece of the puzzle is that at the time we were actually discussing how do we do this, and one of the options was like, maybe we should just rewrite SQLite. And we had a lot of experience in our previous company, Scylla. Scylla was a reimplementation of Apache Cassandra in C++, fully compatible. And maybe we over-index in the fears that we had going that route. We say, hey, the problem with Scylla is that it took a long time for us to put in the market. SQLite is much smaller, so maybe we can do it. But maybe because we had just come from an experience where we wrote a database, we figured that forking was a better strategy. So at the time, our decision after much deliberation was, we're not going to rewrite SQLite. We are going to fork it instead, because then the main advantage is that you have something tomorrow, because you start from a code base that is already working, and then we're going to start making changes to that. So that was libSQL. Like libSQL was essentially at the time. I mean, and the story of Limbo, if I had to tell the sanitized version in which the fork never existed, it would be the same up until this point, right? Because all of those things, like we were, all of that, it's still valid. It's just that at the time, a year and a half ago, we decided that forking was the best alternative. And I'm happy to go into the why, but now we decided to try, okay, what if we had done that one of those options that we consider, what if we just rewrote it? And then when we put it out there, the results were, I've never seen anything like that before. So just, that's the story.
I think the public domainness of SQLite is unique. I think the not open to contribution is also quite unique. Very valid in the, in quotes, open source world. And even they say on this public domain page they have, where they say warranty of title. So if you are a company that needed something where you needed to be indemnified against the copyright infringement or anything happening inside this code base, it gets to be a little bit hairy trying to use SQLite in unique ways beyond. So it kind of makes sense, some of the challenges you had, and that maybe the fork made the most sense, but ultimately the rewrite seems to make the most sense, because what you want is the attributes of what SQLite offers the world, but not the, and I don't want to say it like a negative thing because it's great, but it's dominated very well in the marketplace. I mean, it's used on Mars, I believe, right? It's not on Mars.
It has trillions of databases deployed, right? So
yeah, I mean, like it's not. And Dr. Richard Hipp is one of our friends. We love him. We think he's an amazing person. But I think you are right, though, that the public domainness and the not open to contribution makes it challenging, because that, and Dr. Richard Hipp even said on this podcast in the past that the test suite is proprietary, in the fact that it's not in the open, you can't see it. So making these large scale changes, so to build on top of what is SQLite, if that's your desire, becomes just problematic.
This was one of the big contributors for us to revisit that decision, was exactly the test suite. So, and again, it's not that we didn't know about it. It's just that we thought things would go one way. But look, just I I always love to, if I may, to use opportunities like this to clarify something, because when you're telling a story, when you're saying something, it's easy for people to misunderstand you. So I always want to make this 100% clear. There's nothing wrong with SQLite and the way they manage their community, right? So sometimes people assume that because we went this direction, we believe that what they're doing is wrong. And I want to clarify that that's not the case. I think the beauty of having different people with different points of view coming from, different backgrounds and doing things differently is exactly that you can experiment with a lot of models. And those models have advantages and disadvantages, and it's fine. So that's not the way we believe, we truly believe. And the goal we have with Limbo now is really to replace SQLite. So we believe that we can build something much better if we're able to tap into the creativity and the dynamism of a modern open source community. We believe that, which does not mean that what they're doing is wrong. And it's just the choice that they made, and we make a different choice. It's okay, right?
Well, I'm glad you make that explicit, because as an observer, I remember your initial announcement, and maybe it's because of maybe the social baggage of what a fork implies, but
exactly, yeah.
My initial impression was, and I don't remember the words that you use anymore, it was 2 years ago, but I was like, they see you and your team seemed a little bit upset, or, you're kind of disappointed with this, and so we're going to fork and do it a different way. And it's hard to do that without ruffling feathers, or without getting, even if you don't mean to, people think that you're angry or mad or whatever,
Yeah, exactly. And we spent we did spend a lot of time, by the way, crafting that message. But regardless of how much, there's always like some room for misunderstanding, which is why I always appreciate. Now, I also don't want to run from it. I want to make something clear. We disagree technically with that decision. Right? It doesn't mean we think it's wrong. There's nothing like we don't think badly of them. They clearly created something very successful. But the way Pekka and I always run open source communities, and the way we always participated in open source communities, for us, this component of like being able to tap into the creativity of the community was always something very important. And you have to put it in context as well. That Pekka and I grew up in the Linux kernel community. Right. And a lot of people say this about SQLite, or SQLite has to, and with that, I disagree. SQLite being what it is has to be kept as this very small thing, because that's the whole beauty of SQLite. And again, I disagree with that, because if you look at Linux started as this project that would only run on x86 computers and et cetera. And today it is an operating system that runs everywhere. It runs very well on the server. Pekka and I work together in memory management for very big box machines, like how to make sure that when you have 2 terabytes of memory in 2010, which was a lot of memory back then, it's still a lot of memory today, but like those algorithms to manage memory don't take 3 minutes and hang up the system. It's a problem that doesn't happen in embedded devices. And Linux still runs on embedded devices. So through this big community, you actually can create something that runs well everywhere, and don't necessarily have to make those compromises, right? So we don't agree that SQLite has to be protected and has to be maintained by this single individual to be the success it is. But look, who knows? Maybe I'm wrong. Maybe I'm right. We act based on what we believe, right? But we don't believe there is anything wrong with what they're doing. We just think that it could benefit from a different direction.
But you do believe that you can replace. You said we believe we can replace SQLite.
100%, and we will.
Okay.
And I want to clarify that now, because with libSQL, it became very clear to us in maybe a month that was not going to happen. Right. So with libSQL, I joked about it today. We had this goal of replacing SQLite for 10 minutes. Because it's a dream, etc. It's obviously a big prize. It's obviously this big prize, and etc. As I wrote in my blog post, were we bummed about it? No, because we built a pretty successful business on top of the code that on top of libSQL, which is today our company Turso. So for us, it was this exercise of, like, if you heard the expression, shoot for the stars, because even if you miss, you're going to hit the moon. For us, it was like, it turns out I don't think it's going to be possible for us to replace SQLite with the fork. But that's us hitting for the stars. We didn't hit the stars. We hit the moon. The moon's great. Like, again, we built a super great project. We're having fun. libSQL brought something to SQLite that wasn't there, which was like the serverless, running this on serverless environments on the cloud platform, syncing databases. One of the things that we do with Turso is that you can sync your databases between different devices and the platform and backups and all of that. And this is going great. I mean, this is going fantastically for us. And so we were never sad or disappointed that that this thing that crossed our mind. Man, can you imagine how amazing it will be if people just start using our fork instead of SQLite? We were never disappointed at that. But when we put the rewrite out, it became very clear, and I've been using this analogy from chemistry, that the reaction was right. Like libSQL was something that the market was clamoring for. Like I think what it became very clear, seeing the reaction of Limbo now, is just that the activation energy is not enough to make the reaction happen. And after talking to a lot of people, and I want to tell, there's a whole story of what happened after we announced this. I talked to a lot of the people who started contributing to the project. And what it became clear is that they all wanted, like they all agree with us that like we need a better version of SQLite. I mean, it will be fantastic if you have something like SQLite, but does this all our original vision. But the fork just wasn't differentiated enough. It just wasn't ambitious enough. It just wasn't bold enough to get people to come and contribute. Furthermore, it is actually very hard to do because one of the things you did mention, like the SQLite's test suite is fully proprietary. So once you start making changes that are very deep into the core, you start hitting a bunch of issues, and some of them is just like yourself saying, I know that the best way to solve this problem is this, but I'm going to solve it in this other way, which is almost as good, but not great, but it's less risky. So you start having this on your mind. So the fork never really unshackles you fully to go pursue this, which is why when we announced the rewrite, what we saw, like again, was something I've never seen before. We got 8,000 GitHub stars in a week, essentially. We had, what I consider to be for the first time in the history of computer science, a Hacker News comment section that was mostly positive, with just a couple, I think maybe one or two comments only that were trying to denigrate us, but the rest very supportive. We had this fantastic, inspiring story of this individual who is in prison at the moment. And he was one of the first people in the United States to be granted access to the internet in prison. He can access Discord, but not X, by the way. Maybe say something about it. But he is now the 4th top contributor to the Limbo project.
It's amazing.
And many, many other things. I mean, the level of contributions that we started to get. We started getting like people running this on the browser. Like a week after we announced, like it was running on the browser already. Like just like this, compiled to WebAssembly. All from contributions from third-party people. Again, on libSQL, we did get a lot of contributors, but they were all contributing to the drivers, to the server, things at the margin, which they're important as well for an open source project. But with Limbo, we actually managed to see our dream, like the 10-minute dream come true. Like we're going to build a community of people coming here and writing this database with us, right? So we revisit it. Now it's no longer a 10-minute dream that went away. Like we truly believe now that once we get the momentum going, we can replace SQLite. And that's the goal.
Well, I think you hit a great chord as you've given evidence to. I know my guttural response to Limbo was quite a bit more positive than mine was to libSQL, just by reading the announcement post. I'm like, okay, this makes a lot of sense. And then I realized later, it's the same people that tried libSQL a couple of years back. And it seems like with a rewrite, there's just so much more to do. It has its own identity. There's fresh and new ideas. And whereas a fork almost comes from a different place. And so I think you're absolutely describing it. On the testing front, though, I would imagine it's got to be just as hard, or maybe I would expect it to be harder with a rewrite. What makes it easier with a rewrite than with a fork if you still don't have a test suite?
Your intuition is correct, by the way, which is one of the things that all things consider. We went with the fork because at least there's some level of guardrails that come with the fact that at least that this code that you're importing was tested by this proprietary test suite. It
started off right. Yeah.
So I don't think your intuition is incorrect, but something amazing happened. And by the way I look into the situation, another thing that I want to make it clear, I don't actually think that we made a mistake with the fork, because if we were rewriting back then, there were many decisions that we made today that we would not have made, but now we did because we had the experience. We've been running the Turso platform, and we learn a lot of things. So it actually I almost see it as a prototype, and it actually allows us to make tremendously good decisions with the Limbo project. And one of them is exactly the testing. What happened is that Becca and I got hooked into something called deterministic simulation testing. And deterministic simulation testing is a very niche thing that most people have never heard about. I had heard about it like a couple of times, but I didn't truly quite understand what it was until I met Yoran. So Yoran is the founder of, and I can say this, I mean, even though I am the founder of a database company, Yoran is the founder of the most amazing database company I've ever seen. Although now I think with Limbo, we have a chance to reclaim that title. Yoran and I are going to fight about it. But, ask me a month ago, I would say, man, I have to give it to him. This is the most impressive database company of all, Tiger Beetle. Tiger Beetle is a database, just to keep it very brief, that is designed for financial transactions. So it's completely written in Zig, and their goal is to replace entire systems, the bespoke systems that most financial institutions have to process transactions, right? So if you're selling to banks or and financial institutions, if your goal is to like replace the backbone of world's commerce, it's pretty hard to do, right? And one of the challenges that you have is just this, like, how do we trust this thing? And Yoran found a solution for that. The solution that Yoran found was to write Tiger Beetle entirely with a technique called deterministic simulation testing. Deterministic simulation testing is essentially a fuzzer. So it will generate a bunch of inputs. It randomly generates as many inputs as it can on the space of possible inputs. And this is the disadvantage. You kind of have to write software in a special way to lend itself to deterministic simulation testing. It's very hard to bolt it to an existing code base, right? But you write it in a way that every single operation that you do on I/O, on thread scheduling, everything that happens goes through a special interface that abstracts all I/O, and then you plug a simulator. When you're testing this, you plug this into a simulator, and the simulator is included in the code base. So what the simulator does is that it's going to explore the space of possibilities, create the most arcane, impossible situations ever. And then when something breaks, it gives you the exact steps deterministically that everything in the system had up until that point. So debugging those problems become very easy. So in record time, Tiger Beetle managed to create a system based on deterministic simulation testing, which is their database, right? And the stories that Yoran would tell is like, look, we found this bug that would only happen if you would call fsync on a disk, and then fsync would return an incorrect result, and at the same time, a packet would come from the network. I mean, he would describe like this most complicated scenarios. Oh, and then and the end result of that, the simulator gives you a seed, and you type that seed into the simulator. Now you have every single step that happened to make that happen, right? So this is one of the things that led us to believe, what if we try the rewrite? Because we knew that we could now try the rewrite using deterministic simulation testing. And then we also partner with a company called Antithesis that offers like a almost like the integration test analogy for deterministic simulation testing, which is a full system version of that will simulate like things between machines. It will simulate the network. It will simulate like hardware failures and stuff like that. So whatever bugs our simulator does not catch, usually we just you give it to Antithesis the next day. Antithesis catches the bug. So we knew that that was the missing part of the puzzle, and then with that we would be able to actually create something that probably even surpasses the level of testing that SQLite has. But here's the catch: it is easier to do this on the rewrite because you have to write the system with this in mind from the get-go. It's not something that is easy to bolt upon, right?
Huh. Is that popular enough that you can go out and there's, Rust crates that will give you this functionality? You have to write all this DST stuff yourself?
All of yeah. So for people who are interested in DST, but don't want to go through the pains of just rewriting all sorts of things like that, I truly recommend taking a look at Antithesis, because Antithesis is amazing. It's the second, it's not just the second next best thing. We use it in conjunction. It's not an either or. The analogy that I have is that our own DST is like unit tests. Like we can run centuries of possibilities in 2 days. And it's very fast, all things considered. And antithesis is like integration tests. Right? So you wanna have both, and we do have both. And antithesis has been a great partner for us. But the problem with deterministic simulation testing is that once you start importing other crates in Rust, for example, you have no idea what those crates are doing. Those crates are calling IO. So we even you kind of have to write everything. So it's not even that you have a crate for deterministic simulation testing. Is that like you might not even want to import like something super simple 100%, but you don't want to import anything that does IO that has a timer. You want to write those things. So it's something very hard to do for a general purpose testing. For a database like TigerBeetle, for a database like Limbo, it's worth it. And the scope is quite limited, right? And you don't want to be importing crates all the time anyway. TigerBeetle is way more insane than we are. I mean, they have a policy that they just don't have dependencies. That's it. They write every single piece of code. That we try to be a little bit more flexible, but we will not import a crate that. And again, it also depends because SQLite comes with a CLI.
Right.
If you want to import a crate that does whatever crazy stuff to implement callers in the CLI, that's fine. But for the core of the database, like we try not to import anything that could potentially do IO because we want to make sure that everything goes through the simulator.
This DST sounds like magic. Like that,
It
absolute
is
magic.
It does.
Yes, man.
If it's like writing unit tests, what exactly? And you said that the rewrite is better because you have to write, assuming this DST is in place. What actually is the writing and the creating of this deterministic simulation testing? Like, what is that? Like, how do you do it?
Yeah. So again, the simulator itself, like you just write like a couple of scenarios, and again, it's not truly magic because you do have to write the simulator, right?
Sure.
So the simulator just writes imagine, for example, a workload, and the workload is like generate a couple of queries and then write, etc. But the simulator will include a fuzzing element to that. So we will, instead of like generate this query that I wrote in the unit test, you give it almost like a query generator, and then it starts like generating random queries. And then you start like in the simulator itself. What happens, imagine this, like if you want to write to a file in any software, like you would call a operating system API like write. If we talk about Rust, it's like a fs write, and then you write to the operating system. When you're writing software for DST, you don't do this. Like you have your own IO interface abstraction, and then all of your IO goes through this. So when you're running this in production mode, your abstraction for write just called the operating system write. But when you're running deterministic simulation testing mode, your abstraction for write runs the simulator code that will start injecting failures into this. And again, injecting failures in a deterministic way, because then if the query fails because you injected a IO failure at that moment, you will be able to replay that session, piece by piece.
As my friend that runs, he used to be on Screen Rant. Wow. I'll just leave it there. I'm sure.
Is that the guy that
it's barely inconvenient?
Very easy, barely an inconvenience.
Yeah, that's right. Super easy.
I love that guy, man. Yeah, super easy, barely an inconvenience.
Wow.
That's what I'll say right now. That's how he respond.
So how do you rewrite SQLite with the confidence that it will actually have the level of trust the SQLite acquired? It's super easy, barely an inconvenience, right? All you have to do is write the deterministic.
I love it.
Just throw a DST at it. So when you talk about SQLite compatible, that's Limbo's goal. There's a lot of different fronts that has to be on. Like, are you talking file, structure? Are you talking syntax language? Are there performance compatibility? There's all kinds of things that SQLite is. What's Limbo's goals with regard to these different areas of compatibility?
First of all, compatibility in a project like this, and this is the experience that we gained at Scylla when we were like rewriting Apache Cassandra. Compatibility has to be like a one-way street, right? You don't want to shackle yourself and say, I will always, because sometimes, for example, to implement a new feature, you have to do it in a different way. So it's usually something, hey, if we're going to offer you the same feature set as SQLite, we're going to read your SQLite files, we're going to execute your SQLite code, and if you're not using any of the specific features that we have, we can generate SQLite files as well. But the moment you start using new features that are only present in your implementation, it's impossible to be compatible.
Right.
It's just not possible. So that's Limbo so far, and this is something that we want to keep. Like the language is the same. Like again, we want to keep the language. We want to keep the ABI. We want to be able to load SQLite extensions. The file format obviously it's the thing that defines SQLite. So obviously, again, we might add to it in the future, but we'll be reading SQLite files normally. And we bytecode. We are bytecode compatible as well. So one of the other ways in which we test Limbo is by now out of the simulator, just generating random SQL statements, and then seeing that the bytecode that is generated by Limbo is the same bytecode set of instructions that is generated by SQLite, right? So that doesn't catch bugs in the implementation of the bytecode, but at least you know that the query plan is the same, and et cetera. So this is yet another way in which we've been testing to make sure that it's up to standards.
So I mentioned at the top that it also has some ambitious goals. One of those, fully asynchronous I/O, which is quite a bit different than SQLite, right? So how do you accomplish that but maintain this compatibility?
Yeah, so async is something that a lot of people misunderstand. Async doesn't mean, for the Rust-minded people in the audience, to be clear, async does not mean that we're going to use a async runtime like Tokyo or like others. I actually personally wrote a sync runtime when I was a Datadog that's still around, called Glomio. We don't use any of that. And again, part of the reason we don't use any of that is that we want all of that to go through our simulator. So if you look at the Limbo code, it's just really sync Rust. It's not async Rust, right? So all that async means is that when you call an operation, if that operation is not ready, it will return to you instead of blocking. And the main, now I'm getting a little bit too technical, but let me just give you, the full context. The SQLite CAPI has a bunch of functions, but the most important of them is called SQLite step. And SQLite step is essentially like, you take another step in processing this query for me. And this is a blocking function. So what that means is that if you call SQLite step, it will block until it resolves. Let's say in that step, you want to do you want to execute 4, 5, 10, however many bytecode instructions. Until it does that, it will block. In Limbo, if you detect that you're not ready to execute those bytecode instructions at that time, you just return something saying, no, right? Call me back later. So that is essentially what async means. And then with that, it becomes very easy to plug something like Tokyo on top in Rust or run it on the browser or whatever, because you can call those async functions, right? And if it's not ready, it will not block. That's all that means. But it doesn't mean that we have to use the async runtime internally. In fact, quite the opposite. Right?
So what does that unlock for you? Because SQLite historically is sync, but super fast because it's right there in process and stuff. But
it isn't. Well, it isn't that fast. And I run a query yesterday, for example, that took 10 minutes to run. There is a query with 5 joins, looking at all the user data about users who are signed up to the Turso platform. It takes a long time just because the query is complicated. SQLite is very fast for CRUD style, right? Just like, hey, here's the key, give me the value. So that.
Sure.
But it's not super fast for analytical stuff. So the first thing that it unlocks is just this, like queries that are much more complex that you can run in dashboards and things like that. And also, like for the serverless environments, Turso being one example. And for clarification, I'm going to start. Our product will be renamed to Turso Cloud, and we have all the intention in the world to rename Limbo to just Turso. Limbo is just not a great name, just a parenthesis here. And it just, the story, it's all in the blog post, but we never expected this level of support. So we just came up with a made up name for it that means nothing, right? Mm-hmm. But now we'll address that. But our product, the Turso Cloud, allows you to do like serverless SQLite on the cloud. You have a bunch of HTTP requests there in the middle. It allows you, for example, to host your data on S3, because if you have your data hosted on S3, your query now is not necessarily super fast because you may be hitting a page that is not local, right? So it allows you, for example, to run SQLite with partial storage, like with most of your data on S3 and some of the data locally. It allows us to do allows us to run on the browser, because the browser, as you know, is a very sync unfriendly environment. Like if you block everything, the page just doesn't load. So all you have to, in the browser, you have to be async. So there is a lot of things that it unlocks in terms. In fact, the one thing that Limbo doesn't even support transactions. There is, it's very, very early, which for a lot of people who came to contribute, they actually saw as an advantage. Just because you come with this energy and there's so much to do,
Right.
but we're not even yet at the point that we support transaction. And the one thing that is already different and is resonating a lot is the fact that it is async.
Well, you put a lot of thought behind this, not expecting it to be so well received. You put so much, it seems like just so much thought in the design of it, from the DST, to async to all the things. But why were you so surprised it was so well received?
Technically, we put a lot of thought on the product. And the full story there is that, first of all, like we consider, as just revisiting, especially if people are joining now, we consider rewriting SQLite from the get-go anyway. So this was always on our mind. And we added to libSQL. So one of the things, if you download libSQL today in the fork, libSQL comes with vector search out of the box. You don't have to install any extension. You can do your RAG pipelines of SQLite out of the box with vector search. It was very, very hard to do. It was a ordeal to actually get vector search working. And there are lots of things in the syntax. Earlier, when I was saying you might do it one way, but then you end up doing this other way, which is more conservative because vector search was the thing that I had in mind. Like many things in the syntax, they're okay, but they're not great because we had to be a little bit more conservative. And then Pekka started thinking, and this is all on Pekka, he started thinking, okay, how would that look like? How would that look like if we were to rewrite it? And our goal was something like, hey, look, if this project keeps going and it goes well and it's an experimental thing, like maybe in 2 years, in 3 years, we can make something out of it. So we were very thoughtful about the technical decisions that we were making, but everything around the presentation was just like, yeah, whatever, man, whatever. So again, this was not on our company's GitHub. This was on Pekka's personal GitHub. He spent 10 seconds thinking about the name and then just wrote on said it's going to be Limbo because it's a state of confusion. Like we don't know what we're going to make of this. Mm-hmm. Like the whole story of the name Limbo was essentially, Pekka, what are we going to make with this? I have no idea, right? I just want to experiment with this concept. The logo, he just asked ChatGPT to generate. We took another 5 seconds, so there was not a lot of thought on the presentation and publishing, but there was a lot of thought about the technical side because we thought that, hey, maybe in 2 years, maybe in 3 years, there is a play for us once we are a much more established company to tackle rewriting SQLite. What we did not expect is that as what we decided to do is just make it a official Turso experiment. But if you read the posts in which we were announcing this, we were very clear. We don't have a roadmap for this. We don't have any. Don't ask us what our intentions are. There is nothing that we want to do with this one on the short term. This was an experiment on Pekka's GitHub that actually did pretty well, and it did pretty well based on 2 metrics. We got 1,000 GitHub stars, and we never talked about it. And we got 2 incredibly good engineers that started. One from Red Hat, who is now with us. I mean, so we hired those 2 engineers. We got 2 incredibly good engineers that started contributing to the project. Again. And it was just a project on Pekka's GitHub. Mm-hmm. So we knew there was something there. And we decided, let's just now publish it as a official Turso experiment. We wrote in the blog post, maybe if that goes well, in 6 months, we can start pouring some of our resources and then we're going to see what happened. So we had some idea that this would be useful at some point. We just did not know it would be so well received to the point that it was. To the point that we changed our entire company strategy now to be able to pour our whole weight of our resources behind the project, right? And that's what we're going to do.
So you're all in now.
We're all in. And we in fact, we wrote a blog post last week telling the story, a lot of what we're discussing here. Hey, I mean, this is, and look, in my wildest dreams, I would expect maybe this to gain like 2,000 more stars in a month or so. Then from 1,000 goes to 3,000. Maybe a couple of other engineers that would come and contribute as well and start slowly, but we would see some potential on it. that was my definition of success. And every single metric that we thought Limbo could be successful at, we saw 3 times more, 4 times more than what we anticipated, right? So we decided to go all in, and there is a blog post that we wrote recently with all the changes that we're going to make to the platform to allow us to do this, with all the changes that we're doing to the company. We had a lot of reorganizations internally, and this is really something that we decided in a couple of weeks in January. Because we just like, how can we ignore this? I mean, it seems very clear to us now that the world at large really wants a evolution of SQLite. Like the signals are very strong. So I think we just need to get behind it, right?
What do you think made those 2 contributors that were so pivotal contribute? If this was an experiment on Pekka's personal GitHub, it wasn't like from a technical level well thought out, but just an experiment. What was compelling to them?
Yes, and again, those 2 individuals in particular, they are now working for us, and we hired them already last year because they're great. And it's back, and I'm like, man, if Limbo has no other value, it's a great hiring tool for a company, right? Because it's attracting this kind of people. But those are people, of course, that we have direct access to, so we talked to them extensively, and all the others that came as well after. We had 32 contributors to Limbo the day we announced it as a Turso experiment. Days later, we had already 60, and we're reaching 70 now. And again, a lot of that very core contributors doing a lot of great work. So Pere and Yuse, those 2 contributors are obviously the first ones that we talked to. And the story is always the same. And it's exactly the thing I said. They were very excited about the prospect of like a better SQLite. They knew about libSQL, but libSQL never enticed them because it just wasn't, in Yuse's word, it just wasn't crazy enough, right? Which I translate to bold. But it just wasn't like, it kind of caps where you can go because of all, you're still shackled by the fork. So when they saw this thing and I think you add a sprinkle to that as well, too, man, this is a new project, so there's so many things to do, which engineers get attracted to some extent as well. But if you talk to them, again, it's always the same story. I love the vision, and I already loved the vision when I heard of libSQL, but this thing here is just the right amount of ambitious that I want to start devoting my time to that, and I want to be a part of that as well. So that's exactly, and we wanted to, one of the things that we said a lot in the early libSQL days is that we said that a lot because we heard from a couple of people, a couple of companies even. We love the idea of what you're doing because it gives us a seat at the table. And then my interpretation of that is that it turns out it's actually pretty hard to give people a seat at the table if you don't own the table. So Limbo gave us this. I mean, it's our table now. Now it's a table that is modeled after another table, but we own the table, and now we can really truly give those people a seat at the table. I mean, they're coming, they're writing code, they're contributing, they're reviewing code, they're helping with the direction, they come out with ideas, things that we never consider, things that will not be a priority. Like the thing, SQL already Limbo runs on the browser. Somebody showed up today. Oh, I got libSQL to compile, run the Limbo CLI in WebAssembly, and now I'm distributing the CLI. It's not even something we would have done, but the person took an interest because of it doesn't have a ceiling. You essentially can take this anywhere. Right?
So does libSQL just go away then, or be replaced outright?
libSQL came to be a little bit, and a part of that because, again, as I said, after we had this dream of replacing SQLite for 10 minutes, and then it became clear that it wouldn't happen. So we had this something that was very valuable. We knew it was valuable, but we had to struggle a little bit more with what do we do with that. So the libSQL project today is 2 things. It's a fork of SQLite with some of those changes like vector search, but it is also, and it's all in the same repository, it's all part of the same project. It is also a server implementation to do serverless SQLite over the wire. So that is what libSQL is.
Okay.
It's an open source project, so we're still going to be maintaining that. But the client side part is going to be full Limbo. Like we intend to eventually get all of those things we've done, like vector search, all of that. libSQL is still maintained for the time being because, again, we have a business around it. We have features that we depend on, but our goal is to eventually port all of those features to Limbo, which again we plan to rename to Turso, and then the client is that, and libSQL can become just the server implementation as an open source alternative to do that. Right?
And is there trailblazing left to do, or have you done the trailblazing and now it's just a matter of work?
There's so much. There's so much because one of the things that we heard as we launched libSQL, for some reason I'll never forget that individual. So we create this Discord community. We announced libSQL. People came, and one person in particular, but others said the same thing as well. Give me better schema changes, and I'm switching to this tomorrow. So one of the areas, for example, the SQLite is really bad at is schema changes. You can make schema changes, but you cannot alter the type of a column. There's all sorts of limitations like that, which is something, by the way, that we made better in libSQL. So libSQL does better schema changes than SQLite, but it's not better enough. Same story, because we were limited in what we can do. So we want to run replication, like native replication to the browser, which is something like people have been asking us for a long time. Imagine you have this SQLite database running on your browser that can then sync with an external server or S3 or whatever and just get pages on demand. That's one of the things we want to do. We want to tackle the problem of schema changes. We want to tackle the problem of write throughput, because SQLite is a very bad database for write operations. We want to make SQLite much better. We want Turso much better for analytical workloads. So there's just so much that we believe we can do, right? But together with all of that, there is also the boring work of, we don't even support transactions yet.
Right.
And again, some of that you can do in parallel, like async, like browser, but some of them is just time in the saddle. Right?
How much time do you think? Are we talking months, years?
9 months to a year.
9 months to a year. Okay.
For two reasons. First of all, because of the deterministic simulation testing. Because it allows you to move with a lot more confidence. Imagine trying to get you into the thought process of a database writer. It's always like, I want to make this change, but I don't fully understand the impact that this change will have in all of those environments that I don't control, like running on an embedded device here, running this, so making changes to systems like that, again, and those are the kind of systems that we dealt with at Linux. Sometimes Linux has a lot of weird stuff in the process of development around the idea of, like, we know that this thing can break on a processor that only 3 people have in the world and it's not supported anymore. And we don't want to break those things. So we always move very, 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 very carefully. And the deterministic simulation testing just allows you to make a lot faster, like paired with antithesis, which is our integration testing in this analogy. It just allows you to move so much faster. The second reason for why we believe like a year is the reasonable time frame here is a SQLite, as it turns out, and that's why one of the reasons we believe in forking and now in rewriting is not the biggest code base in the world. SQLite is not that complex. If we were rewriting Postgres, it's a completely different story. But rewriting SQLite, it's actually doable in a year. And also, as I said, we're going to put the whole, we're not going to do this in Q1 because we're treating our first quarter of the year as a transition quarter to allow us to finish other work so that we can be free to do this. But we're going to have like at least 7-8 engineers just working on it full time, right? So imagine that you have 7 people working on a code base that is less than 200,000 lines big for 9 months with a deterministic simulator that catches all possible bugs that you can muster. Like, we believe it's a very reasonable timeline, like 9 months to a year.
So next January, we'll be talking about, is it production grade? What 1.0? What does it look like?
Next, yeah, we want to release a 1.0 much earlier than that, because we want to, we'll see. Like, we still believing in like release often. Just put it out there.
Get it out there, yeah.
A lot of people are going to be early adopters. A lot of people, I think, like our thesis that it doesn't even support even without transactions. There's a lot of people that with a little bit more support on the read side, they can already use it, because a lot of workloads for SQLite, like, you get the file, like, you don't write to the file, you get the SQLite file from somewhere, and then you just run a bunch of stuff on it. Right? So even without writes being fully supported, we believe there's a lot of use cases that this unlocks. So we want to be very aggressive with like making releases, but the moment we're going to say, hey, like, this is stable, and look, we can actually even give us more time, because it's a great commitment to say something is stable. I mean, people trust you that this is going to work. So we can take even more time than that to say, hey, this now has our seal of approval. We're going to support all of that. But much earlier than that, it can already be production ready.
How does this all affect Turso, the business, and how does it fit in? This is going to, I assume it's going to be an MIT licensed thing, open source.
Yeah. So our business is going to change. We announced recently a lot of what we need to do is that we need to simplify our product a lot. So we had a very, very hard decisions to make. So again, it was a tough time for us to go through those decisions, but we knew we kept the mission in front of us. We kept this idea like we need to make those changes because I think the community now trusts us to rewrite SQLite, which is like the biggest prize we believe. So we have to make those changes. A couple of features that we have. Some of them, that I love. A lot of users, unfortunately, got quite upset with that. Obviously, I mean, are features that they use and came to trust. We will discontinue. So the way we're doing this is that if you're a paid user, after a certain cutout date, you're going to be allowed to keep using those features. But new users, new signups, anybody else who is not a paid user at that point will no longer have access to those features. With that, we believe our platform will become a lot simpler. We're still going to maintain our platform, but again, we think that having a single person just running the platform will be enough. And we're not going to be investing in having new features into the platform. So the platform will essentially go, which is the Turso cloud, will essentially be a place where you can still run. Like if what we do today is good for you, great. And what we do today is two things very well, especially after those features will be discontinued. You can access SQLite over the wire from serverless environments. So you have a serverless managed SQLite database. And we have our features, pointing time restore for backups, branching. We have all of that a serverless database needs. And you have syncing of databases between devices, servers, etc. So you can start with your SQLite file, and you can upload that file to Turso and then replicate that to other SQLite files that you own. That's the platform. We're not going to be investing too much in new features, in front-end features, in like quality of life features. The platform will essentially go into a freeze for a year. And the platform is pretty good. It's at a position that we can afford to do this. And then for 1 year, we're going to go all in getting Limbo to replace SQLite, right? And that's it. And then at that point, you can, Limbo then becomes the thing that we run on the platform. And we have the money, we have the running to do this. I mean, it's all accounted for. So if we manage to, which I believe it's very doable, to get Limbo in a production-ready state in 15 months, our plan still works. But 9 to 12 is what we're thinking here.
When you get to that place, whenever Limbo becomes Turso and Turso Cloud goes away, how will you differentiate this new launch? Like, how will you?
No, Turso Cloud doesn't go away.
Okay.
What is Turso today it's called Turso Cloud. Mm-hmm. And then Turso, the embedded database just becomes Turso. And again, this is a lesson that we learn. Not that we haven't heard this before, but I think we're just stubborn. People kept telling us, it's very hard to create two brands. It's very hard to create one brand. Two brands is even harder. But the reason we kept those things separate, and the reason libSQL wasn't called Turso, was exactly because we wanted to give people the sense of, this is a welcoming community. We have our business, but your interests will be heard, right? Like Linux. We model a lot of that on the experiences we had at Linux. Very few people care about this, and that's the lesson that we learned, right? Just almost nobody. Of all the reasons that we heard for people not contributing to libSQL, this was never something that showed up. Never, ever, ever, ever. And then when we announced our changes to the Turso platform, we had many questions from many people about, hey, this feature that you're going to discontinue, this other thing that you're not going to support, and what happens is nobody asked about the name. Nobody said, well, if the name Turso, you're going to, nobody cares, right? So this idea that we had, that we have to keep things very separate to create a welcoming community, we learned that nobody cares. So we're gonna take the opportunity here to just fix it. Because again, it is true what we heard from many of our advisors. Creating a brand is already incredibly hard. Creating two brands is very hard. And the people in the know, they know, but people who are just hearing about it, like now you have to explain that, this is this and this is that. So we're going to just consolidate the names. Mm-hmm. And Turso today, again, is the cloud offering, that is going to be renamed to Turso Cloud. And then what is Limbo, which is the client offering, will just be renamed to Turso, and that's it. And we're still welcoming. We still want people to come and build this with us. We just learned that the name doesn't matter, right?
How do you manage that relationship between the open source Turso, the interests of Turso Cloud, third-party contributors who may want Turso to go a different direction that maybe you don't want it to? Success brings all kinds of challenges.
It does, and that's why what we decided to do is never port the server code to Limbo, right? Because then the server can be kept completely separate. And I think the reason we had the server and the client together was exactly because it was clear to us after a month or so that we would not, with libSQL, with the fork, achieve our goal of really just replacing SQLite, which, this goal that we had briefly. So the best strategy then became have the server code here as well, because now there are other things you can do with this open source project. But with the success of Limbo, it's back on the table, and it's a very realistic goal that this will replace SQLite. So we just revisited the strategy and said this has to be just the client-side library, exactly because of this, because we don't want to be in a position, and the name was a part of that. We just learned that it doesn't matter, right? But we don't want to ever be in a position. We want to design things in a way that we are never, ever, ever in a position to even think about, we would like to, there's a contributor coming with this code, and maybe we don't want to merge it because, this might affect our business. You never want to be in this position. In fact, we want to make people in the community maintainers as well. We want to have people, hopefully like Preston, the person that I mentioned that is in prison, and others that are doing fantastic work. I mean, if they keep working for another 6 months or a year, and you see that they're committed to the project, they should be maintainers as well, and they should have the ability to just merge code, without talking to us. That's what we want to see. So the way we're going to structure things to make that happen is that our business now has to be just the cloud, and then all the code for the cloud that is a separate project, right? That's going to be its own thing, and then the client. SQLite, for example, they don't have encryption at rest. They don't have a bunch of things because they do try to build a lifestyle business around it, as far as I understand, by selling those things. Right? They're very specific. We want all of this in the open source for us. We want all of this. We want encryption at rest. We want all sorts of extensions. We want everything that runs on the client to be 100% open source.
Very cool. So how will you know when Limbo/Turso has made it, has arrived, has replaced SQLite? Will it be on Mars? Will it be on trillions of devices? Like, when will you think it's here?
I think that if this was a consumer business, is when your mom calls you to say that she's using it without knowing that this is the software they work on. I don't think my mom's going to use Limbo or Turso or SQLite or whatever. So I can't use that. So the criteria for us is really when we can see somehow through some fuzzy metric that we've got, like we have 1 billion databases out there. So, SQLite has 1 trillion databases, and I think that we don't think we're going to replace SQLite in a year. That's not the goal, right? But we think that in a year we can get to this point where, hey, we got our first billion. Like, this is clearly working. Just let you do this for another 2 years, you do this for another 3 years, you get there. So the first milestone that we have in mind is that when we can, through some proxy, because a lot of that you cannot measure, but we have a good level of confidence that we have 1 billion databases in the open. Then I think, okay, that's success, right?
If people wanted to play with it today, how much is there? What could you play with, if anything?
A lot of the read stuff works. And one of the things that Pekka, and this was entirely Pekka's idea, that he did very well, and he was very praised by a lot of people, including those contributors. Some of them said, this is one of the reasons I contributed, is that he wrote on day one, because technically this was very well thought. We thought about everything very well on the technical level, just on the presentation that we didn't have a lot.
Sure.
But there is a compatibility matrix. So if you go to the repository, there is a file there, compat.md, that is linked in the README, and there is a full compatibility matrix with everything. So what you're going to see there is like the read stuff from SQLite already works pretty well. So you can, in a lot of ways, if your queries are not the one I run today, with 10 joins and very complicated use cases, the basics of like reading from a SQLite file, they work already.
Adam, any other questions for Glauber before we let him go?
I'm just trying to understand this future, I suppose. And I'm trying to piece it together, and I don't know how to ask this question necessarily, but I'm reading your most recent roadmap where you mentioned changes to our server implementation. And sorry for my stuttering because I'm still drastically behind on my breaths because of getting over the flu. But client side, open source, server side, closed source. And so libSQL is Turso Cloud. And if you want to self-host,
more or less, because we just to add to that, like it wasn't something very relevant, so I didn't bring it up. But we already had, for other reasons, we already had a proof of concept of a new server implementation that is not based on libSQL. And the reason we did this is that we also want our server to have deterministic simulation testing, right?
okay,
So that new server will be closed source. libSQL, so that is the change. That's one of the changes in strategy that we're making. So that, and again, we understand that in a perfect world, everything will be open source. I would love that. But the reason we're doing this is that we want to have this very clear separation without concerns of what goes where. And we think the best way to do this is if the server is fully proprietary, right? And the client is fully open source. So libSQL is open source. The protocols are all the same. So you would be able to run your Turso Cloud databases on libSQL. That's the goal. But the new server that runs deterministic simulation testing, that has a lot of additional features, that is designed to be multi-tenant, the design goal that we had is that we will be able to run queries to 1 billion SQLite databases in a single box. So all of that, like that level of scalability, we're going to keep it closed source. Right. So that's going to be the dividing line. And then libSQL still exists as a reference implementation. If you truly want to run a open source version, it wouldn't even be I think it's more accurate to say if you want to run an open source implementation of our cloud platform, libSQL will do this for you with limitations. But our new server, we decided not to, seeing the success of Limbo, we decided not to release that as open source to keep things clear. And then Turso, the embedded database is 100%, 200% if we can, open source.
200%, gotcha. So in the future, when somebody runs Limbo, which will be renamed Turso, they can run that on their own. But if they want this massive scale multi-tenant world, they've got to host with you.
Yes, or write their own implementation, right? Or use libSQL again, which is still going to be there, but we believe our implementation is going to be better. That's why we didn't.
So you're long betting on hosting a lot of databases in the future.
Yes.
Okay.
Yes.
You said you don't need money, right? So you have the runway for the next 15 months. You get in danger zone.
We have runway for more than that. Like everybody needs money, so
no need to raise more now though to get to this goal.
We don't need to raise more money now. Yeah, that's right. For more than 2 years. I mean, I've been talking about 15 months, not as a cutoff point for that. It was more about like when do we believe that this can become. But we have capital for a lot longer than that now.
Okay, good. That's let's talk in a year, I guess. I mean, that's all the questions I have for now, for the most part. Everything else is speculation, but there you go.
Send me an invitation today for a year in the future.
Right, January 22nd, 2026.
Same time, same date. How about that? Yeah.
Exactly.
Let's do it.
Let's do it.
Thanks, Glauber. Hey, we're rooting for you. This is really exciting stuff.
Thank you.